Hey everybody, welcome. In this lesson, we are discussing the image intensifier, its purpose in fluoroscopy, its components, and how those components work together. The image intensifier is an important component of the imaging chain because it brightens the fluoroscopic image so that it can be of diagnostic value. In fluoroscopy, either a continuous or pulsed X-ray beam is used to create dynamic, real-time images of internal structures. Because of this increased exposure time, a lower MA is used to reduce patient dose, and because of this lower quantity X-ray beam, the initial fluoroscopic image is dimmer than those in static X-rays. The image intensifier helps to brighten the image by amplifying the lower quantity X-ray beam. What are the components of an image intensifier? The components of an image intensifier are an input phosphor, a photocathode, electrostatic focusing lenses, an anode, and an output phosphor. These components are encased in a metal housing which protects the glass or metal envelope that maintains a vacuum and houses all the other components. An anti-scatter grid is often also included within the outer housing of the image intensifier and is placed in front of the input phosphor. Finally, there is a video camera or charged couple device or CCD and an analog to digital converter or ADC to visualize the radiographic image on a viewing monitor. So, how does an image intensifier work? First, the X-ray beam passes through the patient and reaches the anti-scatter grid. The grid reduces the amount of scatter radiation that passes through to the input phosphor. This reduction in scatter radiation will increase image contrast. Then, the incident X-rays strike the input phosphor, which is typically made of cesium iodide. Cesium iodide can convert a small number of X-rays into many more light photons. In fact, if one incident X-ray hits a cesium iodide input phosphor, that X-ray is converted into 1,000 light photons. Also, the tightly packed, needle-like shape of cesium iodide crystals directs the light in straight lines, preventing light dispersion and improving spatial resolution. The next component is the photocathode, which is directly bonded to the input phosphor. The photocathode is a thin metal layer usually composed of cesium and antimony compounds that respond to stimulation of input phosphor light by the emission of photoelectrons. When the light photons emitted from the input phosphor stimulate the photocathode, photoelectrons are released through photoemission. Photoemission is similar to thermionic emission, where heat releases electrons. In photoemission, light releases photoelectrons. At the other end of the image intensifier tube is a positively charged accelerating anode with a small hole in the middle which the photoelectrons pass through to strike the output phosphor. Because the path from the photocathode to the hole in the anode needs to be exact, the image intensifier tube is lined with negatively charged electrostatic focusing lenses. The electrostatic focusing lenses are positioned in such a way that they help to funnel the photoelectrons into a concentrated stream. This photoelectron stream passes through the hole in the accelerating anode and hits the output phosphor. The output phosphor is made of zinc cadmium sulfide. The output phosphor converts the photoelectron stream back to light photons. Let's take a closer look at the last steps of this energy conversion process. The anode is positively charged with 25,000 to 35,000 volts. The strength of this charge works to accelerate the negatively charged photoelectrons toward the anode and causes them to gain kinetic energy. This is called flux gain. Another benefit of funneling the photoelectrons from the input phosphor into a smaller stream onto the output phosphor is called minification. The process of minification gain is part of how the image intensifier uses the same number of photoelectrons emitted by the larger photocathode to brighten the image on the output phosphor. This is similar to how a magnifying glass can intensify a sunbeam. The same amount of light is coming through the magnifying glass, but because it's concentrated, it is intensified and can become hot enough to light a fire. We'll explore flux gain and minification gain in more detail in a different lesson. Now, once the photoelectron stream passes through the hole in the accelerating anode, they hit the output phosphor. They've gained a lot of kinetic energy in their journey and strike the output phosphor with up to 50 to 75 times more kinetic energy than when they left the photocathode. When the photoelectrons strike the output phosphor, it converts them back into visible light. Since we are left with light photons at the output phosphor, we need a component that can convert the light photons. CCDs can convert light photons to electrical signal and collect that electrical signal. This collected signal is sent to an analog to digital converter, which converts the signal one final time into a digital signal that is sent to a viewing monitor. There are a lot of energy conversions happening throughout this process. X-rays are converted into light photons, which are converted into photoelectrons, which are converted back into light photons. These light photons get converted again into an analog signal, and finally, that analog signal is converted into a digital signal. Let's try a practice question. Which of the following combinations is the correct order of the image intensifier components? A. Anode, input phosphor, output phosphor, electrostatic lenses, photocathode. B. Photocathode, input phosphor, electrostatic lenses, output phosphor, anode. C. Input phosphor, photocathode, electrostatic lenses, anode, output phosphor. D. Output phosphor, electrostatic lenses, photocathode, anode, input phosphor. Take a minute and try to figure it out on your own. The answer is C. The order of components of the image intensifier is input phosphor, photocathode, electrostatic focusing lenses, anode, and output phosphor. Remember, the X-ray photons travel through the patient, and the remnant or exit beam reaches the input phosphor. X-ray photons are converted to light photons at the input phosphor. The photocathode is attached to the input phosphor and converts the light photons into photoelectrons. The electrostatic lenses focus the photoelectrons toward the anode. The anode accelerates the photoelectrons toward the output phosphor. The output phosphor converts the photoelectrons into light photons. In summary, the image intensifier works to increase the brightness of the fluoroscopic image while reducing patient dose. It is composed of an anti-scatter grid attached to metal housing, which protects the envelope that houses the input phosphor, photocathode, electrostatic focusing lenses, anode, and output phosphor.